embedded within smaller or medium grain rocks. So such crystals are surrounded by mass of smaller grain called ground mass. The smaller grain or the fine one, this small one that you cannot see with your eyes, are called ground mass or matrix. Okay? In a metamorphic rock, you call it porphyroblastic texture. So if this picture is shown to you, or you go to the field and you see a rock that has fine grain and coarse grain, and you have seen that this rock is a metamorphic rock, you call this texture porphyroblastic texture. Are we following?
Yes, ma'am.
All right, thank you. So in the metamorphic rock, most times the larger grain grew during that metamorphic process. Sometimes they are the same grain sizes from the beginning, but with metamorphism, some minerals will grow faster due to high temperature, or they remelt and come together to form larger grains. That's coarsening. That is one of the major characteristics of metamorphism. The rock gets, the mineral grains get larger, they get coarser. So another texture that you're going to see in your igneous that I want you to note here is this particular texture called idioblastic. Hello, are you following?
Yes, ma'am, I'm following.
All right, thank you. So idioblastic is a mineral grain that shows perfect crystal shape. Okay?
Yes, ma'am.
All right. In igneous rock, she's going to teach you. I brought it here because she has not taught you that. In igneous rock, it is called euhedral. You can hear that the grain, the mineral grains are euhedral in shape or in habit or in form. Habit or form is the shape of the mineral. But in metamorphic, you don't say euhedral. Euhedral is for igneous rocks. You say idioblastic. So if you say the rock has idioblastic mineral, or the garnet or the sphin are idioblastic, I automatically know that you're talking of a metamorphic mineral. Do you understand?
Yes, ma'am.
Then you have hypidioblastic. The other one, you can see that the size or the shape of the mineral was perfect. You can see it here. This is what its fin look like. But here you can see that the edges are not showing very well. It means that this mineral, the shape has not formed properly. Okay? During the growth, the crystal shape is not perfect. It is called hypidioblastic. While in igneous, it is called subhedral. Subhedral is in between euhedral and anhedral. Anhedral, not perfectly formed. Subhedral, intermediate. Euhedral, perfectly formed. That's for igneous. But for metamorphic, you have idioblastic, perfectly formed. You have hypidioblastic, intermediate. Then you have xenoblastic. Xenoblastic is when the crystal shape is not even formed at all. You can see. This is a mineral under this section showing scattered. It just grew anyhow. The crystal, the shape did not form the perfect shape of the the mineral. Okay. So in
Okay.
xenoblastic, no clear crystal is formed. Okay, which is
Yes,
anhedral in igneous terminology. Are you following?
yes, ma'am.
Yes, ma'am.
So here you can see porphyroblastic rock now. You can see the large grain embedded in smaller grain. You can see this large garnet inside the smaller, fine, darker one, darker or lighter one, but the garnet is the red one. The same thing, you can see a very large garnet crystal now inside finer grain. These are all metamorphic rocks. Same thing here. Fine grain, coarse grained. Finer grain, you can see some larger, coarser grain inside. Fine grain, coarse grain. Okay, so this is what a porphyroblastic metamorphic rock look like on the field. So the difference between porphyroblastic and I don't want to take you people too much inside because it's going to confuse you people. So let's leave it at that porphyroblast, because by the time I start bringing porphyroclastic now, it's going to be confusing to you people. Because last year, most people failed the 2 questions. So let's leave it as porphyroblastic. So another texture you're going to see on the field when you go for your field work this time is gneiss. Is a gneiss. A gneiss is a very high grade metamorphic rock. Remember, I just showed you how the grade moved from slate to phyllite to schist to gneiss, right? A
Yes,
gneiss
ma'am.
is a high grade metamorphic rock going towards migmatite. All right. It has
Yes,
this characteristics thing called augene. Augene is a rock with large oval feldspar crystal called augene. Augene is a German word that means eye. It's eye-shaped if you look at it here. Okay?
okay.
So this is a
Yes, ma'am.
highly metamorphosed rock. You are going to see the feldspar inside of it like this. Okay? You're
Yes,
going to
ma'am.
see garnet inside of it like this also. It can be garnet, it can be feldspar, but most times it is feldspar. So they are formed from the pressure that flattened the gneiss is what flattened and dragged this mineral, okay, to form what is called this augene. Dr. Bankole is going to show you all this on the field. But I
Sorry,
expect you
ma'am.
to have an idea thank you, so that when you get to the field, you can follow easily. So this is what they look like on the field when you get to the field. You're going to see a lot of this. I brought different types for you to see. The one you're going to see most on the field in Abeokuta is going to look more like this. Some big like this, some like this, but they are all augene. So if he asks you what texture is this, you should be able to explain that this is augene gneiss. Okay.
Yes, ma'am.
So, all right, you understand this right?
Yes,
Yes,
ma'am.
ma'am.
All right. So we'll look for another texture you're going to be seeing on the field. Is a gneiss. This is a gneiss. But when it formed that kind large crystal that are dragged, you can see the dragging that it has been stretched due to
Yes,
pressure.
ma'am.
That's when it is called augene
Oh,
gneiss. Okay, it's a nice rock that has eye inside of it. Augene is the eye. Is a German word that means eye inside of it. So it's a gneiss. So this is what your gneiss looks like on the field. You're going to see a lot of this. This lower one is called banded gneiss. I'm sure some of you have seen a lot of these rocks, but maybe you don't know what they are called. Have you seen rocks like this before?
yes, ma'am.
All right. So they are metamorphic rocks. It means they've undergone metamorphism. Okay. So
Yes, ma'am.
you can easily tell by the foliation. We're going to be looking at foliation later. You can see the minerals are all aligned in one direction. Then you can see banding. This banding tells you that the temperature was high. I'm going to explain that in the next slide. it tells you that the temperature was high enough to start kind of partially melting this rock, so that you have the low temperature mineral like the feldspar coming together, and the high temperature mineral like the biotite and the hornblende and the rest coming to separating from each other. Okay, it's a kind of separation. You can see here under this biotite now that separation is not serious. Okay, this is biotite. Biotite, the separation is not serious. But by the time you get to banded gneiss, it means the separation has started taking place. So gneiss is a medium grained, irregular, banded rock where the bands may consist of examples of layers rich in mica. You can see this layer, dark layer rich in mica, alternating with layers rich in quartz and feldspar. You can see the light colored one, quartz and feldspar. Look at it here, the same thing, the same thing. Here it is not very obvious, but the second one, you can see the banding has started forming. The first one too, the banding has started forming. So it has a poor schistosity due to the abundance of non-tabular quartz and feldspar, but it does have neosity. That means it's gneissic. I'm going to explain all that later. Gneiss it has formed kind of alternating band. It has started separating from the light colored one to the dark colored one. That's what it's just trying to explain to you. So this is another rock you're going to see on the field. It's called a migmatite. Migmatite is also a metamorphic rock, but it has undergone some kind of partial melting in some parts. Some part has not undergone melting. It is generally a mixed rock. Migmatite is generally defined as a mixed rock. It contains in a migmatite, you're going to find banded gneiss. You're going to find rocks and gneiss that have not been banded. You're going to find veins. You're going to find intrusion of pegmatite. So migmatite is a kind of mixed rock. So they are generally gneissic rock also, but they contain veins. They contain layers of granitic material that has not been altered. They contain those that have been altered and partially melted. Okay?
Yes, ma'am.
Thank you. So they represent the uppermost extreme of metamorphism. They are the highest grade of metamorphic rock that you can find, where the metamorphic rock has started becoming igneous again. It has started undergoing melting. You know, when it started, I told you from the beginning that once melting starts, it is no longer igneous. It has started becoming a molten rock again, which is an igneous process. So migmatite is the highest grade. It's in between the metamorphic going towards igneous process, but we have not entered igneous process. So you are still in it is the highest grade of metamorphic rock you are going to see on the field. Are we following?
Yes, ma'am.
All right. So are you understanding?
Yes, ma'am.
All right. So you're going to, we've already explained that the major characteristics of, one of the major characteristics of metamorphic rock is foliation. Foliation does not characterize metamorphic rock because we have unfoliated metamorphic rock. We are going to see that classification later. I am going to see all the rock types under unfoliated. So there are rocks that are unfoliated. There are those that are foliated. But under those that are foliated, I want you to understand what foliation is and what brought about the foliation. So foliation are planar features, okay? It is developed when minerals like mica are orientated parallel to each other. They have been redirected to lie parallel to each other due to the temperature and pressure of metamorphism. Okay? Another thing that you're going to learn during this course is lineation. It shows parallel orientation of prismatic minerals like hornblende. Okay, what I'm going to do is I'm going to give you example assignments. Your first CA is going to be an assignment. Are you listening?
Yes.
Okay. I want you to extensively distinguish between foliation and lineation. Is that okay?
Yes, ma'am.
All right, thank you. You can use diagram, whatever you can use to explain the difference between foliation and lineation. I want that as your first CA. It's going to take 10 marks. If it's taking 10 marks, so we have 20 marks left. Okay?
Yes, ma'am.
Thank you.
Sorry,
So
ma.
I
Should the
may,
assignment be written or typed?
you say?
Can it be written or we should type it out, ma? The assignment.
You can type it out if you want to, you can handwrite it, but just make sure it's legible that I can read it. Okay?
Okay, ma. Okay, ma.
If you don't have money for typing, I don't prosecute students. If you don't have money, some people are just struggling. So if you can write it, make sure I can read it. Is that okay?
Yes, ma'am.
Yes,
And if you
ma.
have money to type, you can type it. It's not going to be more than 1 or 2 pages. It's something simple. Explain the difference between foliation and lineation. It's not something difficult. Don't just go and look for one Google unnecessary definition for me. I want geological definition. Do you understand?
Yes, ma'am.
Yes, ma.
Thank you. So we're still looking at foliation. So we're going to look at, I will leave this maybe one after your assignment before I come back to explaining the difference between foliation and lineation, because it's difficult to understand for some people. So after your assignment, I can come back and explain that, okay?
Yes,
So I'll
ma'am.
just jump it for now. So let me jump here now to how foliated rocks formed. Remember, I have shown you this already. I've explained to you that it is the processes that form the rock that alter the rock, the high temperature and the pressure, okay? So foliated rocks, okay, here I said metamorphic rock can be foliated, they can be non-foliated, okay? So for the foliated rocks are classified on the basis of the intensity of the foliation, which is the degree of the mineral separation and the crystal size. The lowest grade of foliated metamorphic rocks are called slates. We're going to look at them later. The next one is phyllite. Okay, let me start with this. The lowest grade of foliated rocks are slates. Slates are metamorphic shale. You know shale?
Yes, ma'am.
All right. Shale, when it undergoes metamorphism, the next state is slate. Okay? The next state after slate is called phyllite. Do you understand?
Yes, ma'am.
All right. So slate are metamorphic shale, and like their precursor sedimentary rocks, they are fine grain. Shale are very fine grain, like mudstone, that are deposited into the basins, into your sea, your ocean, wherever they were deposited initially. So they are minerals, fine grain minerals, plenty minerals that were deposited on top of each other. So when metamorphism starts, okay, and you have prolonged temperature and pressure altering this rock, the platy minerals will start regrowing. They will come together, melting, forming larger grains, number one. Number two, they will now be stretched depending on the direction of the pressure, okay?
Yes,
That is when you now have phyllites. Phyllites are metamorphic rock of slightly higher grade than slates. They are characterized by distinct foliation. Foliation because the minerals have been stretched in one direction, so that they now have a glossy sheen This sheen is caused by the alignment of the plating minerals that developed. It gives it a pearly surface. So foliation has to do with planar fabric, okay? Typically,
Yes, ma'am.
realignment or flattening of minerals such as mica. So I don't want to go under your structural geology, you're going to be taught the rest. I think you're starting structural next year. You're going to be taught the S-tectonite, the direction of pressure that affects the rock, all that. You're going to be taught all that under structural. That's not my own EU. So here, this is what the rock looks like initially. You have your grains, original rocks. All the sides look the same. But when pressure is applied, you can see here compression. There is a kind of flattening called foliation. That is stretching of the minerals in one direction. Okay?
Yes, ma'am.
So that is what happens. I'm still going to show another example for you to have good understanding. Here, you have minerals. You can see the grain size scattered. Pressure applied in this direction will make them to become foliated in this direction. So that you have recrystallization or formation of new mineral in response to pressure. Remember, I told you index mineral grows due to temperature and pressure. Here you have the same minerals, but when the temperature and pressure affected, you have two minerals here because some mineral recrystallized under the high temperature to form a new mineral, which are generally the index mineral. So as temperature continue to increase, you have continued recrystallization, and you have continuous formation of, who is making noise? You have continuous formation of new minerals. That is, new mineral assemblages will continue to form. That's how metamorphism increase. And the stages of metamorphism increases from slates to from shale to slate, slate to phyllite, phyllite to schist, schist to gneiss. Okay, this is the process. Temperature, pressure, recrystallization, formation of new mineral, realignment, coarsening of the minerals. That is what is happening under this temperature and pressure. So we go to the next slide. Why is it not moving to the next slide? Okay. So you can see this diagram here. It's showing you the stages of what happened. The first one is shale. Shale is a series of rocks that resulted from either regional metamorphism or which other metamorphism can form? Metamorphism can form change sedimentary mud stone to shale. You have, when you're during regional metamorphism, what generally happens is that those low-grade sedimentary rocks. Can you hear me?
Yes, ma'am. I can hear you.
Okay, my internet was shaking. You have your mud stone that were deposited, your shale, your silt. Okay?
Yes,
Well,
ma'am.
because they are fine grained material, and because pressure is increasing from the top due to more rocks being deposited on top of it. Okay?
Yes, ma'am.
You have pressure at the top pushing in, and then you have temperature increasing because it is being pushed to deeper level of the earth where the temperature is higher. Okay? So that this rock will start changing gradually. You have shale will change to slate. Slate will undergo further metamorphism to change to phyllite. Phyllite will undergo further metamorphism to schist. Schist will undergo further metamorphism to change to gneiss. Okay? That is the process that occurs. So here I wrote that petty minerals like muscovite, biotite, chlorite are particularly susceptible to orientation. Okay? When
Yes, ma'am.
you orientate them due to temperature pressure. So that is what is changing. It is if you look at this one, they are scattered, the minerals are scattered. But look at under slate, there's slight rearrangement. Under phyllite, serious rearrangement. Under schist, extreme rearrangement of the minerals. They are all aligned to follow one particular direction. So that is what is happening. It is change in texture that is occurring here. So that by the time you get to schist, the grain size has increased from here. You can see the grain size, and you can now be able to identify the minerals. From mudstone or from silt, now you can identify mineral because the crystallization took place and they grew. The two small minerals came together to form larger minerals so that there's a growth of minerals. Coarsening took place. So this is how the metamorphic grade increases from the shale, the slate, the phyllite, the schist up to the gneiss. So the same thing, I like showing so many examples for you to have good understanding of what I'm saying. Look at your slate or mudstone deposited at the earth surface. As it is undergoing serious burial, here you have serious regional metamorphism taking place here. As it is being pushed into depth, you can see it changes to phyllite. Further pushing, it changes to schist. As it undergoes more pushing, it finally changes to gneiss. So you can see the temperature grade is increasing as you're going this direction, telling you, grade of metamorphism, telling you temperature and pressure is increasing. So I wrote that mudstone and sediments, which can be squashed by burial. I've already explained that at surface, but as burial continues to increase, the degree of metamorphism increases. Do you understand, or do you want me to explain further?
I understand, ma'am.
You understand?
Yes, ma'am. So I said metamorphism generally include a number of textural changes. Okay? Yes, ma'am.
The major changes you're going to see in metamorphic rock, like I said, is coarsening. Coarsening, that is the growing of the grain size. They become bigger. Another changes you're going to see is evening of grain size. They tend to become similar grain sizes, okay? The bigger ones are made smaller, the larger ones, they grow at the same rate. Which we've explained. Foliation is another thing that happens during metamorphism. You have folding. Folding takes place. I've already explained that in the first class. You have stretching of minerals taking place during metamorphism. You have rolling of mineral grains, okay? I should have shown you when I was showing you the garnet minerals. Okay, I'll still show you. I'll still show you when I'm describing the different stages of metamorphosis. I'll still show you that. So you have crushing. These occur in cataclysmic metamorphosis. So all these are textural changes that can occur in a rock during metamorphosis. So we're going to be looking at example of the rock I just showed, which is the slate, right? So what happened from the slate is you have fine-grained metamorphic rock with slaty cleavage. The mineralogical composition of the slate may be difficult to determine under the microscope at this stage. Only that you can determine it. The slate, you cannot say which mineral makes it up at this stage. But when it becomes a phyllite, it forms fine-grained minerals. It becomes a little bit larger. Okay, you can see the grain size. When it becomes a schist, it's a relatively more coarse grain metamorphic rock that you can see the minerals. You can see them with visible eyes. Okay, on the field, we are going to be seeing the micas. You are going to see the biotites. Then gneiss is relatively more coarser than the schist. Okay, that is how the metamorphism increases. And that's how the grain size affects it. So I'm just going to look at, we're going to look at the different classification of the metamorphic rock before next week, okay? I said we have foliated and non-foliated metamorphic rocks. So here you are going to see the difference. Here we have non-foliated, here you have foliated. The foliated are the ones we've been looking at so far. We've been looking at slate, phyllite, schist, and gneiss. Those are the four foliated metamorphic rocks we'll be looking at. We've not looked at any non-foliated metamorphic rocks. So here now we're going to start looking at, we're still going to look at the foliated rocks and see them under the picture, what they look like. Then we'll go to non-foliated rocks later. So under the non-foliated rocks, the finest grain are the hornfels. Remember, the hornfels are those ones that form in contact metamorphism directly adjacent to the heat. So they form very fine grain material. Another metamorphic rock you're going to be looking at is quartzite. A lot of you have seen quartzite. It's a metamorphic rock. A lot of you have seen marble. Marble is a metamorphic rock, but it is non-foliated. A lot of you have seen serpentinite. Serpentinite is a metamorphic rock, but it is non-foliated also. Hold on, please. Sorry about that. I'm so sorry. All right. So if you look at under the foliated, what you can easily use to identify them are the minerals that you find. We've already explained all that, so I'm not going to go back into that. So here, under the texture, the foliated can be coarse grain, they can be fine grain. Under the fine grain, you have the phyllite and the slate. They are the fine grain. While the foliated are the coarse grain are the gneiss and the schist. Gneiss can be banded. Schists are generally micaceous. So I'm going to see the micas in it. Phyllite has shiny layers. White slate has smooth layers. You're going to see it later. For non-foliated, the hornfels are the fine grained. The marbles and the quartz are coarse to fine grain. Then serpentinite is fibrous. You are going to see what fibrous is when we start explaining textures. I think that will be next year, right? So here you have the rock name. Here you have the minerals that characterize each rock types. Okay.
Eva.
So this is what a slate look like. They are fine-grained, low metamorphic grade mineral rock that has distinct foliation. It is foliated in one direction. Okay. So it can have bedding because of this foliation. It has started undergoing, but the foliation is not intense yet. Slate is generally heavy, dark colored, and break easily. Okay, it breaks very easily. Under the microscope, you can see the minerals, but in hand specimen, because it is fine grain, you cannot see the minerals that make up the slate. The property that makes it easy for it to be used for roofing, for table, is because of how it breaks in sheets. Okay, that's why they can use it to make some stuff like tables, like roof. Okay, rooftop. The second foliated metamorphic rock is phyllite. We've already seen this, but I want you to see it in hand specimen now. So phyllite resembles slate because it's just a grade higher than slate. But because it is a grade higher than slate, it means the textures are coarser. Okay, so it means you can now be able to identify some of the minerals gradually so that you can now start seeing the sheen. The shiny mica minerals can now start showing. The surface generally has a lustrous sheen due to the mica or chlorite. It can be chlorite or mica as the index mineral. At this point, remember we talked of index mineral. Most times at this point, you have chlorite and mica as the major index mineral. So the sheen is caused by alignment of plating minerals that developed, giving it a pearly surface. It mostly has this distinctive green color because of the chlorite. Chlorite mineral is generally greenish in color, or amphibole. So those are two minerals that are greenish in color. So they generally impact the greenish. You can see it looking a little bit greenish because of the chlorite. So the third foliated igneous metamorphic rock is schist. You've seen a lot of schist on the field, and you're going to see a lot of schist because most of the rocks you're going to see are going to be schist during your field work. You're going to see a lot of biotite schist or mica schist. It is coarser than phyllite because it has undergone higher temperature of metamorphism. So it now has higher or larger grains of mica so that it has schistosity. You can see the mica foliated and it has this shiny parallel alignment of mica that is visible. Schists are generally named on the field on the basis of the most dominant mineral. Okay? There are different kinds of schists. If the most dominant mineral you are seeing is mica, you call it a mica schist. If the most dominant mineral you are seeing is called is the chlorite, you call it a chlorite schist. If the most dominant mineral you are seeing is garnet, you call it a garnet schist. Okay? There are graphite schist, there's starch schist, different minerals, okay? Depending on major dominant mineral, that's what you call it. We've already seen a gneiss before, okay? It has distinctive banding. What distinguishes gneiss from other from the schists is the banding. Okay, somebody was talking. The banding, I've already explained that to you. When you have banding, separation of the dark colored minerals from the light colored minerals, so that you have accumulated feldspar quartz in one direction. You have the biotite or amphibole or hornblende in one direction, forming banding. That's a gneiss. So it can be called banded gneiss when that separation is highly developed. It is called banded gneiss. Otherwise, it is just a gneiss. So there are three different types of gneiss. Okay, you have the paragneiss and you have the autogneiss. The paragneiss are those that form from metasedimentary gneiss. Then the autogneiss are those that have igneous origin. It's a gneissic rock that forms from an igneous rock, while the paragneiss are those that form from sedimentary rocks. Okay?
Yes, ma'am.
So when a granitic rock becomes highly metamorphosed into a gneiss, okay, it is an autogneiss because its source, the origin is a granitic rock. So even the fact that it was a sorry, it's an igneous rock, the composition still remains the same. The chemical composition, you know, the mineral has a little bit been changed, okay, due to the metamorphism. And then you now have distinctive banding that form due to separation of the feldspars from the biotites, okay? So you should know the difference between paragneiss and autogneiss. So non-foliated rocks now. Should we continue? Have we done 30 minutes, 1 hour, 30 minutes?
Close to.
I don't like exceeding 1 hour, 30 minutes because people lose interest completely. Nobody is listening again. Should we continue or we should stop for today? Huh?
For today, ma.
People are tired.
Yes. Don't want to stress you, ma.
But do you understand what I've taught so far?
Yes, ma'am.
Yes,
So if I give you an exam on what I taught today, you can write it.
My God, that's great.
All right. All right. So we'll see next week. Okay. Is that okay? So next week, remind me because I